Yes, friends, welcome back to PMR School. Today we are continuing the first topic, that's Algebra 1, and we are going to look into polynomials today. We already looked at some concepts of polynomials when we were introducing when we were handling our introductory work. That was whereby we looked at quadratics. Polynomials are just equations which are equations or algebraic expressions which are actually of degree greater than 1. That's why, remember, we have linear equations, we have quadratics, then we can talk about polynomials, but quadratics are just part of the polynomials because polynomials are those sorts of degrees higher than 2. Linear equation, when you have equation like x plus 3, let me say, equals to 0, this linear. Why? Because the unknown, which is the parameter here, which is x, has degree 1. If you compare with the x squared plus 3 equals to 0, this one has a degree 2. When you go see x cubed plus 3 equals to, let me say, 0, we are going to have this degree 3 from degree 2 onwards are known as polynomials. Okay, while this one of degree 1 is known as linear equation, of it's just an expression that's if there's no equal sign equating any side, any different expressions, you can just call it an expression, which would be a linear expression for that case. That's all I can say about that. So we basically, as we continue into this journey of covering pure mathematics, we need to know polynomials very well, and we need to know how to handle them, degrees of higher degrees. When it comes to adding, we already saw a lot of examples when I look at quadratics. Remember, we looked at addition of polynomials. So today we are going to just review this. We're going to do. So remember polynomials, so we could have, let me say, an expression. Let me say we have x cubed plus x squared plus 1 equals to 0. Then let me say, okay, let's give it, let me say, equals to y1. Then another equation, x squared plus x plus 3 equals to y2. Okay, if we are to add these two equations, if you are to have y1 plus y2, we're going to have x cubed plus x squared plus 1, that is for y1. Then we add to x squared plus x plus 3, which is our y2. So for this case, it's just like collecting like terms like we looked at before. We want to see the highest power, which is x cubed, is alone. If you check that, so and we have x squared and another plus another x squared, that means we're going to have 2x squared. Then we have x alone also, then we just add plus x. Then we have constants 1 and 3, we add them, giving us 4, so that we have that, whereby y1 and y2 are considering them to be polynomials. So here, if you want to know, this y1 is to degree 3 and this y2 is to degree 2. Why am I saying that? Because when you're looking at the degree of the polynomial, you consider the highest power in the polynomial, which is, if you see the highest power here is 3, if you see the highest power here is 2. That's why I say consider this to be of degree 1 and degree 2. So we need to know the degree of the polynomial. So we mean here we have degree 3, polynomial of degree y1 is a polynomial of degree 3 and y2 is a polynomial of degree 2. I think that's all we can say about even my subtraction. If we were to say y2 minus y1, we just simply change here. I mean, I can handle that up here for you. If you say y1 minus y2, we are simply going to have x cubed plus x squared plus 1, okay, minus we have x squared plus x plus 3. Okay, then we have here x cubed plus x squared plus 1. Then this minus will open the bracket where we have minus x squared minus x minus 3. If that minus opens that bracket, so we have x cubed is a known, x squared minus x squared will be 0. We don't write it. Okay, then we have there's 0x this side minus that, we remain with only minus x for the case of x. Then we have 1 minus 3 will become minus 2. So this would be our y1 minus y2. So it's just a matter of considering signs like that. So it's for that case we have a big deal. So that's when we are trying to see into how to subtract and maybe add polynomials. We look into another thing which would be expansion. We looked at expansion. Expansion, I'm going to talk about multiplication. Or I can just simply say expansion. Here we're going to just recall our quadratic identities, AB squared, which was equal to A plus B into A plus B. We looked at this expansion in our introductory work and derived them. We had this given by that. Okay, another one we had A minus B squared, which was A plus B, A minus B I mean, into A minus B. We looked at it in our introductory work. It was given by that. Okay, we had another one which was called a difference of two squares, or A squared minus B squared, which was given by A. That one, that's a difference of two squared, which was given by that, and that's all we have, which was actually that, just that, because when you expand that, it means you're going to have A into A minus B plus B into A minus B. Okay, whereby you have A squared here minus AB, then here plus AB again, and minus B squared. See, this would go to 0, then you go back to that. Okay, so another one we looked at was one of whereby we have let me see, we have this, we have yeah, we had only these three basic ones. The other ones are just linear whereby you have two terms, or you have a term outside, then in the bracket you have two, whereby we use distribution, where this could also be a plus or minus. We just use distribution law to whereby this one outside the bracket multiplies each term inside, and you consider the operation either plus or minus. That's all we can talk about expansion. Sorry. So if they give you to expand, let me say x squared plus let me say plus 1 into, let me say, x squared minus 1. You know that you just, this term, each term here will open the term in the bracket. Okay, then plus 1 into x squared minus 1. So that here you have x to power 4 minus x squared, then plus x squared minus 1. We're going to have x to power 4 minus 1. Okay, this could be written, so when you expand, that's going to be like that. So if you see that this is a polynomial of degree 4 now, compares from my multiplication of polynomials of degree 2 giving you polynomial of degree 4. So in case now you realize that if this now an expanded form, if you can even take it back, if you see a difference of 2 squared is the same as having x squared minus 1 squared, which would be x squared plus 1 into x squared minus 1, just like what we saw there. So that's how you can see why when it comes to expansion. That's all I can tell you about. So when you're given from two different polynomials, you're supposed to expand them, applying themselves. Use this concept we had there, the three quadratic identities, which are very important, are these ones. Okay, then another review that we're going to check into was knowing whether when it comes to fractional polynomials, okay, whereby some polynomials are expressed in terms of fractions, whereby it's further split it into proper and improper. So you have proper and improper fractions or polynomials. I can say polynomials or polynomials, or you can say proper and improper algebraic expressions. One of the examples I can give you will be this. Let me check out. Let's first start with proper. When you look at in our introductory work, we realize that proper fractions are proper algebraic fractions are those ones whereby the expression in the numerator has less power compared to the degree of the expression in the denominator. For example, if I have x out of x squared plus 1, this is proper. Why? Because the denominator has a lower degree compared to the numerator. Another one we could say, if I have x cubed plus x squared plus x plus 1 out of x to the power 5 plus 1, this is still a proper fraction. Why? Because the expression in the numerator is greater than, is less than the expression or the degree of the expression in the denominator. Now for the case of improper, we have the other way around. Whereby if the degree of the expression in the numerator is equal or less, equal or greater than the degree of the expression in the denominator, we consider that to be an improper polynomial fraction or improper algebraic expression. Whereby if you have let's consider when they are the same, x out of x plus 1, this is improper. Why? Because they have same degree. The expression here, x out of x plus 1, they have same degree. X squared plus x plus 1 out of x plus 1, this is still considered to be improper. Why? Because the degree of the expression in the numerator is higher than the degree of the expression in the denominator. So we can conclude that if the degree of the expression in the numerator is equal or greater than the degree of the expression in the denominator, then you consider the fraction or algebraic expression or the algebraic polynomial fraction to be an improper one. And now we can the final thing I'm going to do on the review of this and this introductory polynomials, because I know with time we will have to go into maybe solving polynomials, solving some equation, but already we did that a lot in our introductory work. I will try to see whether I can add on something in my next video. And please don't forget to subscribe if you're new to the channel. Please like, support me, and you can add on something in the comment. Make me know about what you're interested in, or if I need to improve on certain things. I would be so grateful. We can give some few examples just to see whether how we can make a fraction proper. The work here is always to see if we can make the improper fraction to be proper. If you have x plus 3 out of x plus 5, this is improper, but we can make it proper. Just like if you have 5 out of 2, we can make it a proper fraction by expressing in terms of 2 and 1 out of 2. Okay, there, whereby you can either use long division. Here you use long division, and just know when you divide that, you can come with a whole number of 2 and a remainder of 1 out of 2, the one that you divided with. But here we can also use long division, or we can simply just play. We can simply just play with we can just juggle our algebra to come out with something. So if you to make that a proper fraction, we can say, let's say we have x plus 3 divided by x plus 5. Okay, since x, when you're using long division or when you're dividing algebraic expression, you know that if x and the numerator is having the same power, or you just see it's always the one in the numerator, you take the first term, that is that x, divide by the highest degree in the one the one you're dividing with, that is your divisor, which is x still here. First term, I'm taking first term, so this divided by that to get what will be there, which is going to be 1. So that 1 now you multiply by each term here, which is going to be that times that will be x plus that times 5, which is going to be plus 5. Then you subtract the result to get, here will be 0, then 3, that will be negative 2. 3 minus 5. So that your result here, that x plus 3 out of x plus 5 will just be that number. Then we have minus 2. I think it's a negative here. So it's minus 2, which is the remainder out of the original fraction. Now you see that x here has a degree of 0, which makes it now a proper, since the degree of x here is less than the degree of x here. So that you're going to have just 1 minus 2 out of x plus 5 as your result. When you divide that, you've made this proper by expressing in terms of that, where this is your quotient, this is your remainder, this is your divisor. So that's how simple it is. So now we can another way we can do maybe that is by just juggling your algebra. Let me say you have x plus 3 out of x plus 5, that okay. What you want to do is you're trying to manipulate this numerator in terms of that, so that you can just write that, denominator, you have the denominator up, but now you want that x plus 3. Okay, what do? You're simply going to subtract 2 from it to get that numerator, but here you let it remain the same. It's like you're not changing anything, but just trying to manipulate this one up here using this one down. So now we have there x plus, so we can simply say now separate the two. Remember, these two, they can on their independent denominator, so it's the same as if you give this its own denominator. Okay, it's going to be x plus 5 out of x plus 5. Then minus this, you also give its own denominator, which is still x plus 5. So that here the result would be 1, and you end up having 1 minus 2 out of x plus 5, which is the same as that. Even with more bulky work, you can still do that. You can still juggle. Actually, the next one I'll try to juggle just the algebra, because I know long division you might be well acquainted with it. Let me say the final example I'm going to give for today's review of polynomials. Let me say I have x squared plus 2x plus 1 out of x plus 1. It's improper, right? We make it proper by just juggling. We're going to cause our denominator to be up there, and we try to create that. Okay, if you want to create x squared plus 2x there, so if I multiply this by x, I can generate that x squared plus x here, but I need 2x, so I can add another x, then I add a 1. Okay, I think what I'm trying to rebuild that from this. So I first take that x plus 1 up there, I multiply it by x to bring the x squared term plus x, then I want 2x, add another x, then plus the other one, so that my denominator will still remain that. Okay, so you will realize that I will remain with x into x plus 1 out of x plus 1. Then I can put here x plus 1 out of x plus 1. If you see that this will cancel out, I will remain with x plus here 1. So what does it mean? If I get that, I'm going to actually have x plus 1. So that means x squared plus 2x plus 1 out of x plus 1 is going to be that. Okay, you might want to confirm that by using long division. This numerator, which is then this divisor. We have I told you that this one divided by the first term here, which is going to remain x. Okay, then multiply by that x squared, then plus x. Subtract, remain 0 here, then remain x here plus 1. You pull down that 1, then still x out of x, you remain plus 1 there. then multiply like that. When you subtract, you end with 0. So what does it mean? Your quotient is just x plus 1 plus 0 out of x plus 1. So you remain with x plus 1, which is the result we got when we were just juggling the algebra. So please, thank you for coming to my channel today. Please make sure you keep following. If you want more stuff, more simple simplifying mathematics in this channel, you can subscribe, like, and share to reach out to that person who might need the video. Thank you for your support.